algebra. We already kind of started at PO59 because I forgot to record, but thank you to observant students who reminded me. What you see on the board is the quadratic formula. Yes, please. The quadratic formula is the only equation that you need to solve for the x-intercepts of a parabola. In PO55, we talked about different methods you could use based on what the equation, what the form is. Some of those methods are more efficient than the quadratic formula. You can see this is kind of a hefty equation here, boys. But the quadratic formula will always work. That's the benefit. Okay? You don't have to decide what form of the equation's in, therefore what method should I use. This one will always work. It's not as efficient, but it'll always get the job done. Okay? What's important, obviously, is to know the formula, but also remember what your A, B, and C values are. I'm going to write the formula again over here just so we have it. We can refer to it. Negative B plus or minus the root of B squared minus 4 times A times C, all divided by 2A. We talked yesterday about other formulas that kind of are embedded in this. We see under the root, there's the discriminant, right? B squared minus 4AC. What's outside of the root, negative B over 2A, that's how you find the x value of the vertex. So they're all kind of related. Okay? They all kind of play off each other to get that graph of the parabola. Okay? So the first one, what's our A term? And I recommend that you write these down on the side so you're thinking about them. You can reference them. What's the A term of this first equation here? X squared is not the A term. The A term is the coefficients to x squared, right? Ax squared plus bx plus c. So the A term is 1. The B term is 5, I heard someone say. The C term is negative 104. And now we go to work, okay? Once you identify what A, B, and C are, first step is just plug them in. You don't have your binder? Okay, if you have Ryan's binder, he is searching for it. Otherwise, take out a separate sheet of paper and make sure you jot this stuff down so you can refer to it later. Okay. So in our formula, negative b is going to become negative 5 plus or minus the square root of b, or 5, squared, minus 4 times our a, which is 1, times our c, which is, I never make this line long enough. You think I'd learn after 16 years. Times negative 104, all divided by 2 times a, or 2 times 1. Notice my use of parentheses to show that we're multiplying. The reason why is because, especially with this squaring here, right? Sometimes you need parentheses when you square, sometimes you don't. If you always use them, then you don't have to worry about that. Okay. Like we talked about yesterday, you can't put this whole thing into your calculator. It's an order operations nightmare. Your calculator does not have the plus minus function. So we're going to break this down. And we're going to start with the discriminant. Okay? Because remember what the discriminant tells us. What would happen if we were to get a negative number under our root? Meaning the discriminant was negative. We could stop. Right? Because the goal of the quadratic formula is to find the x-intercepts. A negative discriminant means there aren't any. Okay? So we start with that because that's going to tell us, do we need to go any further? So negative 5 plus or minus the square root. Go ahead and calculate 5 squared minus 4 times 1 times negative 104. What do we get? Yes, Andrea. It ends up being 25 plus 4, 16. Yes, because this is separated, so you multiply those three things, then add 25 to it. What do we come up with? What is the answer?
Oh.
Just the discriminant. 5 squared minus 4 times 1 times negative 104. 441. Make sure you can get that in your calculator. Okay? Does everybody get 441? Don't make the root yet. Does everyone get 441 from b squared minus 4ac? Okay? We don't take the root yet because if that number were to be negative, it would mean that there are no x-intercepts. We don't have to go any further. The fact that it's positive means we can continue. Okay? And as long as we're simplifying, we might as well do this part too. That part's easy, just the 2a. 2 times 1 equals 2. Okay? Now, what is the root of 441? 21. Okay? So this equals negative 5 plus or minus 21 all divided by 2. And once you take the root of 441, the root symbol goes away. Right? So here is where, because how many x-intercepts are we looking for? 2. Because your calculator doesn't have that plus minus feature to it, here is where we split it up into 2 separate equations to solve. Okay? Brielle, do you remember what you promised me earlier?
Yeah,
Are you keeping the promise? I'm just wondering, are you keeping the promise?
Yes.
Oh, good, okay. Your first equation is going to be negative 5, and now you use the plus part of the plus minus symbol. Negative 5 plus 21 divided by 2. Yes?
Where do you keep the extra tissues?
In the closet right behind you. Open the door on the right, and they should be up at the top shelf somewhere. And your second equation is negative 5 minus 21 divided by 2. So these two expressions are the same, only one of them's got a plus symbol, the other one's got a minus symbol. That's how we incorporate this plus minus here. Because remember, that symbol means plus or minus. Okay? And what is negative 5 plus 21? 16 divided by 2. 8. What is negative 5 minus 21? Divided by 2. Negative 13. So the x-intercepts of this parabola are 8 and negative 13. Okay? Now, putting that in your calculator can be a little bit dangerous. We've talked about this before with the vertex formula. If you use a calculator for this and you put in negative 5 plus 21 divided by 2, why are you going to get the wrong answer? Because of order of operations, it's going to divide 21 by 2 first, and then add that to negative 5. So if you use your calculator for this, make sure you're putting parentheses around the numerator so it does that first, and then divides everything by 2. Maddie?
Calculator really important for this upcoming test.
A calculator will be a very useful tool for the upcoming test. If you don't have one, if your plan is to borrow your neighbor's, he or she will get very annoyed because they will need to use it on pretty much every objective. So bring your own. Bring your own. Colin. Folks, shh. Colin, ask your question again.
How do you know which one to do if there's only one x?
So if there ends up being only one x-intercept, this first number here will be, or your root will be a 0, right? Because if it's 0, negative 5 plus 0, negative 5 minus 0, they equal the same thing. Which is why, back to the discriminant, what discriminant results in just one x-intercept if this equals 0, right? And that's how you're done. Okay? There you go. There's your quadratic formula. The mean.
What about like 0?
What about 0?
0 x-intercepts.
Then this discriminant here will be a negative value. Say that this had been negative 441. Can you take the root of a negative?
Oh.
No, right? And so that will tell you there are no x-intercepts. Maddie?
So would it be x equals 8 and x equals 13?
X equals negative 13.
Oh yeah, sorry.
Okay? And again, just like any other equation, you can check these values pretty easily by going back to your original equation. Does 8 squared plus 5 times 8 minus 104 equals 0? 64 plus 40 is 104. Minus 104 equals 0. Does negative 13 squared plus 5 times negative 13 minus 104 equals 0. Negative 13 squared is positive 169. Minus 65 is 104. Minus 104 equals 0. You can check these answers by plugging them back in. There should be no reason why you hand in a test not knowing what your score is on PO59. Because if you check them, you either know you got them all correct, or you know you got one wrong and you just don't want to fix it. Okay? You can always plug them into check. Yes, Andrea.
So would the next equation on this page not have any?
I don't know. We haven't looked at that one yet. We will do it shortly, though. Sam.
On the test, can we just do the quadratic formula?
On the test, if you want to use the quadratic formula for PO55, you are able to. Like I said, it's not the most efficient method, right? It's kind of long. There are a lot of opportunities to make mistakes. So if you get an equation on the test that's like this, we'll do 2x squared plus 8 equals 0, and you can pull out the GCF a lot faster than doing this, then pull out the GCF, right? This will always work, but it takes a long time, opportunities for mistakes, so it's kind of up to you. But yes, you can, okay? Yes, you can. All right, let's do the next one. 2x squared plus 6x plus 5 equals 0. Let's go ahead and identify our A, our B, and our C. Our A term is 2, B is 6, C is 5. Let's go to work, okay? Negative B, or negative 6, plus or minus the root of 6 squared minus 4 times 2 times 5. Oh, I made mine long enough. All divided by 2 times A, or 2 times 2. That's how we start. Okay? Make sure you put the negative sign in front of the 6. Negative B. Yeah, otherwise pretty straightforward for this one. So solving the discriminant first. Okay, then we might as well do this part too, as long as we're at it. That one's easy. We get negative 6 plus or minus the root. What is 36 squared minus 4 times 2 times 5?
Negative 4.
Negative 4. 36 minus 40 is negative 4. All divided by 4. 2 times 2. And at this point, the reason why we do this, the discriminant first, is because now we can say, all done, right? Because the root of that negative 4 doesn't work out. It's an imaginary number. In context, it means there are no x-intercepts for the parabola. Okay? So no x-intercepts.
You don't just put the circle through the line through it?
It's not that there's no solution. It's that there are no x-intercepts. You need to make that part clear. What does it mean? It means there are no x-intercepts. If you want to abbreviate intercepts to INT, fine. But no x-intercepts is what that means. Okay. Question on that one? All right. Last one. Whole bunch of negativity here. Our A term is negative 4. Our B term is negative 5. Our C term is negative 1. Let's go to work. Negative B. This time it's going to be a positive 5. Right? Because a negative 5 makes it positive. That negative sign is part of the formula, but if our B value is negative, right? Negative 5 is positive 5. And then that's plus or minus the root of negative 5 squared. This time the parentheses are required. Hopefully you're just putting them in there anyway, but this time they are required. B squared minus 4 times negative 4 times negative 1. All divided by 2 times negative 4. Okay. Andrea, have a seat, please. Discriminant first. What do we get? 9. Negative 5 squared is positive 25. You end up subtracting 16. And so they get 9. 5 plus or minus the square root of 9 divided by -8. That first step simplifies this tremendously, right? That discriminant is where most of the algebra is. Once you get that part taken care of, it simplifies it tremendously. We're not ready to split it up into 2 equations just yet. What is the root of 9? Equals 3. So this becomes 5 plus or minus 3 divided by 8, -8. Woo! See, opportunity for a mistake. Don't carry that sign over, right? -8. And so now we make up our 2 equations to solve here. We incorporate that plus minus sign. Our first equation is going to be 5 plus 3 divided by -8. And our second equation is going to be the negative sign, 5 minus 3 divided by -8. What do we get? What's our first one? Joseph?
+1.
Positive 1?
No, wait.
-1. 8 divided by -8
Oh, no, wait, yeah.
will be -1.
Sorry.
And the second one? Real? -1/4. You end up with 2 divided by -8, which is -1/4. Check these. Take the time. Is -4 times -1 squared minus 5 times -1 minus 1 equal to 0? Well, this is 1. -4 times 1 is -4. This is +1. -4 plus 5. I say positive 5. -4 plus 5 is +1. Minus 1 equals 0. If you plug in -1/4 as well, you will get 0 there too. Okay? Questions on this?
Will we have homework?
You will have homework. Sam?
What if there's only one? Like if it's equals 0?
Right. If there's only one, if this equaled 0, let's just pretend. Okay. Let's just pretend that this equaled 0 there. What is the root of 0? 0. So essentially, you've got 5 plus or minus 0 divided by -8. Well, isn't 5 plus 0 the same thing as 5 minus 0? You get the same thing. Okay. So if the discriminant equals 0, you'll end up with only one x-intercept because your numerator will be the same. Okay? Colin.
Why the x-intercepts?
Why we're solving for the x-intercepts is in CO60, we'll talk about parabolas in context. Where parabolas are used a lot, they are like your satellite dish. Those are still satellites. Or those, your cell phone towers, right? Those curved things that collect the signal. How they make those is they lay them flat on a coordinate plane. They lay them flat on the x-axis. And so the design of them comes from a parabola. And what they have to figure out is, what x-intercepts is obviously if you're making, it doesn't go on forever. Below the x-axis isn't going to be a part of it. Do they make it like that? Do they raise it up a little bit so it's a little bit higher, steeper curve? Do they elongate it? Finding the x-intercepts there are kind of like where the top and the bottom of those satellite dishes are. Okay. When ESPN, someone hits a home run in baseball and they automatically have up how far it went, right? It's a parabola. They're graphing from the player's bat how far it travels and where it lands in the stands. What are the x-intercepts of that parabola? Make a coordinate plane, And so it's a very applicable thing in context, and we'll talk more about that in CO60. Okay, Andrea.
What is 0 squared?
0. 0 times 0 is 0. Okay, let's look at the backside because it does get a little bit more algebraically complicated. And let's start with
Second one. Did we do the first one?
no, we're not doing the first one.
Do the second one. The second one, so you look how far everyone is to. Yeah, me too.
Let's do one.
He literally just went over that. Why did you give us a lot of? I don't know, but I have to find the beginning.
Where's my calculator?
What's the root of 68?
Oh, which one are you on right now? The first one, okay. All right, listen up, please. 3, 2, 1, you are quiet. So where this can get a little more complicated, girls, is this first example here. Let's just start this out the same way we did the other ones. Our A, our B, and our C. Our A is 8, our B is 6, our C is -1. Going into the quadratic formula, you get -6 plus or minus the root of 6 squared minus 4 times A, which is 8, times C, which is -1, all divided by 2 times 8. Yes, Andrea?
What happens if we only have like one?
We just went over it. We talked about 5 plus 0 being the same thing as 5 minus 0. And so your numerator will be the same, 5. And so you'll get the same result. Okay? If you want to watch the video, like and subscribe. We talked about it not too long ago. So anyway, so we're going to start the same. We're going to do our discriminants and our 2a here. And so what is 6 squared minus 4 times 8 times -1? 68. So we get -6 plus or minus the root of 68 divided by 16. What's the problem here? Or I didn't say problem, but what's the added challenge, Nick?
It doesn't roll out as a whole number. It rolls out as like a group.
Yes, the root of 68 is not a perfect square. Okay? The root of 64 is 8, root of 81 is 9, root of 68 is going to be somewhere in between. Now we've talked about before, if we take the root of 68, it's an irrational number, which means you're going to have to round it. Then you use that rounded value in this fraction to solve for the eventual x-intercept. What happens every time you round and subsequently use that rounded value in a formula later on? You lose accuracy. So we're not going to take the root of 68 and round it as a decimal. When you don't have a perfect square, you go straight to your solutions. Your first equation is -6 plus the root of 68 divided by 16. And your second equation is -6 minus the root of 68 divided by 16. Now, this is going to involve a little bit of calculator prowess here, okay? Order of operations becomes a bit of a challenge because the root, when you use it, it gives you a parenthesis for you, and so you're ending up with multiple sets. I need everyone to watch this because this is how you should put it into your calculator, okay? You're going to open, I'm going to erase this and do it up here. You're going to open with a set of parentheses. This set of parentheses is going to represent your numerator. Okay? And so you're going to start with a set of parentheses. You're going to put your -6 in. Then you're going to add. And does everyone know how to get the root symbol?
Yeah, 2 and then x squared.
You have to press the second function because the root symbol is above your x squared key. It's up here. So to get that, you first have to press the shift or the second function up in the way top left, and then the x squared key, and it'll give you a root. But when it gives you a root, it also gives you can't avoid this, another parenthesis. Okay? So you put in your 68, you close the parentheses over the root, but then you also close the parentheses you gave it originally. Okay? If you don't put in a second set of parentheses and close it, it's going to divide the root of 68 by 16. So you need 2 sets of parentheses, close them, and then divide by 16. And if you do that correctly, what do you get?
0.14.
0.14?
Wait, then.
Okay? If you didn't get 0.14, go back, check to make sure you have exactly what I have here. Girls, are you keeping your promise?
I was just like,
I got like something really different.
Okay? I'm going to come around and check calculators if you didn't. If you don't have the recommended calculator for the course, it might be a little bit different for you. You'll just have to figure it out on your own. Okay? Did you get it over here? You got it?
I'm trying
Nick, did you get it? Yes. Okay. All right. Now, hold up, folks. I'm going to give you a math hack that will help you with the second one so you don't have to retype everything. If you don't clear your calculator, even if you do, but especially if you don't, down at the way bottom right of the calculator, above your equal sign, what word does it say there? Entry? Oh, hold on. Oh, never mind. Okay, hold on. Sorry, I'm thinking of my TI-83. When you have your answer, go to the four arrows and press the up arrow, and you'll notice it goes back to this equation you just put in and allows you to edit it. What's the only thing you need to change? You change the plus to a minus, and you press enter again. Okay? And what do you come up with? Negative 0.89. Okay?
Yeah.
Yeah. So, if you want to retype everything, you can. Or you can press the up arrow. It brings you back to that equation. You can now edit and change the plus to a minus. What's that? You can still go back up, yes. Izzy. Yes. So you can do this, but then when you're done.
Oh yeah, that's what I was looking I'm already like 0.89.
Sam, did you get it figured out?
0.89.
Okay. Negative 0.89. So
That makes
go back. Did you divide by 16?
Yeah. I don't feel like the whole bubble correction.
So, Nathan, if you don't put in that, hold on, folks. Nathan's asking for the whole double parenthesis piece. If you don't put in that first set of parentheses, and you just do negative 6 plus the root of 68, the parentheses that it gives you is only for the root. So if you were to divide this by 16, it's going to do this first. Okay? It's going to do the division before the adding. So to tell it, no. This is a numerator. You need parentheses around that original expression also. Okay?
So those are the X values?
Probably. These answers, just like the other ones, can be checked.
I just want to test it.
Folks, we're not done yet. Stick with me here. I want you all to check our 0.14. Actually, no, check our negative 0.89 answer. In the original equation, go back to it. 8 times negative 0.89 squared plus 6 times negative 0.89 minus 1. Eight times negative 0.89 squared plus 6 times negative 0.89 minus 1. If you do it correctly, you should get negative 0.0032.
Oh yeah.
Why is it not 0?
Because we don't have a...
Because we rounded. We lost just a little bit of accuracy. Is this super, super, super close to 0?
Yeah.
Yes. So when you check these answers that you have to round, don't expect to get 0. If you get something this close, you're good. If you get something like, even something like 1.1, either you only rounded to the nearest tenth, or you didn't round correctly, or you're wrong. It shouldn't be that far off. Okay? Or you checked it wrong or did something there. But you might not get 0, and that's okay. It's still super, super close. Nick?
So, like, what happens, like, but if you're a doctor and you're off by that much, you could accidentally mix.
So if you were using this for an actual medical thing, what you would do is you leave it like this and enter that expression into your computer, your like whatever you're using to design your thing, because the root of 68 is an exact value, and the computer will not round it.
Well, what happens if you have an old computer that doesn't do that?
Then you should upgrade. It's 2023. Okay.
21st century.
Okay. Your homework for tomorrow is to work on the rest of the page. No, but I can look. Keep in mind, folks, keep in mind here, you need to make sure your equation equals 0 before you start the quadratic formula. So for example, this one here, it's not ready to be quadraticized. Okay? It must, Paisley, it must equal 0 first. So that negative 16 over on the right must come over to the left. And some of you that have had to retake slope intercept form over and over again because you're not changing the sign when you move that x term over. When you move this negative 16 over, make sure you change the sign. Okay? Make sure you change the sign. And there you go. Now you can quadratize. Okay? All right. Questions, comments, concerns, complaints, compliments, congratulations, criticisms on that goal.
So when you for the first step, let's say you do it and then you get 0, is that no x intercept stuff?
No. What does the discriminant of 0 mean? 1 x intercept. Still solve it out. You can take the root of 0. You cannot take the root of a negative number. That would mean there are no x intercepts. Okay? Sorry this was a bit of a long lecture lesson today, but it's a long concept and lots of different tricks, things to keep in mind. Check your answers. That's the best way to know if you're doing it right. If your answer doesn't work, check signs first. Did you miss any signs? Make sure your A, B, and C are in the right place. Make sure you put in your calculator correctly. But this is something where if you come and ask me, did I get it right? I'm going to say, did you check it? If your answer is no, I'm going to say, check it. And if your answer is yes, I'm going to say, then why are you asking me if you did it right? Okay, because you can tell. Plug those values back in. See. All right. This is going to be due on Thursday. I'm not going to be with you in class tomorrow. My 4-year-old has their last day of preschool ice cream party during class. I'm not going to miss an ice cream party. So this will be due on Thursday. Hopefully that will ease the burden of 11 questions a little bit for you. Right? That's how I math.